Hi everyone, thanks for coming. I just want to do a quick run through of us and what we do for those of you who don't know. Basically, Vertex Agility, the consulting arm of Vertex Solutions. So we basically set up Vertex Agility to provide support to our clients on a remote project basis, essentially. So at the minute we're providing both remote and on-site solutions to, well, a variety of customers between like startups going to larger management consultancies as well, and some of the bigger tech players in the game. So we're doing quite well so far. It's done well. So in terms of our specialisms, we really try and focus in the software, infrastructure, data, cloud and security space. We've done a lot of work in the leadership space as well. We've built a number of successful teams across the globe that sit within these spaces. So I'd say that's our specialism really. Doesn't mean that obviously if there's anything else that sits outside of that, we're not going to be able to work with you on, but it just means that we'll get faster response in these areas. I guess what makes us a bit different to other consultancies is the fact that we actually build bespoke project teams. So rather than, let's say, shoehorning or body shopping a person into a role, we will actually go and find someone that's the exact fit for that need. We verify them, so we do background checks. We speak to people that they've worked with in the past to make sure that they can actually say what they can actually do what they say they can. I guess as with the technical consulting arm of the recruitment business, it takes us always back to staff augmentation. We can still do staff augmentation, definitely, but it would be something that Vertex Solutions would pick up rather than Vertex Agility. So obviously Vertex Agility sits primarily in the consulting space. So that's us. So yeah, pass on to you now, Soumen. Thanks, guys.
All right. So my name is Soumen Trivedi. I've been working with Vertex for almost 3 years now, a little bit more than that. And essentially, one of the key topics that I think I found it's something which is picking up a lot of heat in the market, and people are talking about it. It's about machine learning and using Kubernetes. So I thought might as well just put some of my thoughts in here and share with all of you. By all means, all the content that you see in this is readily available on the internet, maybe in a different form. So probably my language might be a bit different to how I'm presenting. But now, if you have any questions at any point in time, feel free to just ask me questions. I think it's best if we keep it more of an like a communicative two-way dialogue sort of thing, rather than me just blabbering through lots of slides. Just to assure everybody on the call, I'm not going to do a PowerPoint to death. So we're just going to have maximum 8 slides, and slides are very light touched. I just want to talk more about machine learning and take it forward from there into Kubernetes world, right? So just going quickly, we're just going to briefly touch upon machine learning. So we keep hearing this word ML or machine learning, ML ops, and all different kind of weird technologies that we are famous about. In the IT. So we're just going to just talk briefly about what's machine learning. For people who know it, sorry, it's probably a maybe a revision. And then what are the existing solution or framework that are helping to deliver machine learning, and what are the challenges essentially enterprises face particularly, and why is machine learning on cloud becoming more and more prevalent, and then obviously Kubernetes probably being the savior around how that fits into the whole piece. I will like to do a bit of a explanation around Jupyter Hub, Jupyter Lab, and Kubeflow. This is purely for people very technical, but essentially just to make sure people understand that they are different products and they're not actually vis-a-vis comparisons. So I've put there. and then we're going to do some demos, just to see how things go. So just brief about me. I'm Soumen, working as a DevOps consultant, working myself to become a cloud consultant in future, full time. And essentially, I live in the UK. Been working for almost 16 years now in the IT, and I have a very young family, 2 kids. Live happily near Southampton. So that's all about me. So quickly jumping into machine learning. So I think, you can read the slides. These slides I can share with you after the session's done. If you could ask Danielle, probably she could share a PDF copy with all of you. But essentially, machine learning is categorized into 4 different kind of 4 different categories. One is supervised, unsupervised, semi-supervised, and reinforcement. So supervised is something like I keep receiving data, I know how to perform, and I keep working on that. If there is new set of data which falls under the similar kind of category, I know what to do. So like chatbots, which is also triggering the AI-based chat ops system. Essentially, what it does is there is a rule engine. Chat notifications keep coming on a chat. It keeps reading, and then it knows how to react and kind of things. But the key thing over there is all the data comes as tagged or labeled, and the chatbot or the AI system over there, the machine, understands this and works upon it. Unsupervised is completely opposite to this, as you see. Basically, it works on unlabeled and untagged data. Essentially, this is never used to do output-driven kind of things. So you never get an output out of unsupervised machine learning. It's more about data exploration and understanding the structure of the data. So basically, all different raw feed is given into the system, and the system then starts identifying things which match the. So just assume you're having a cluster of lot of items, and you put it into the machine through the scanner, and what the machine's going to do is start segregating. Okay, these are of a particular type, these are of a different type, and that categorization is the unsupervised machine learning. Now, this is essentially useful for anomaly detection. So, for example, if you were expecting a cluster of data coming through your data pipeline, and suddenly if some kind of weird data comes in, unsupervised machine learning can immediately pick that up. Supervised, semi-supervised, and reinforcement take a longer time to get through. Semi-supervised is learn from past, apply on new set of data. So basically, it has a model built in, and it's the machine's already trained. It knows how to perform, but all the data that it's actually getting may or may not be labeled and tagged. So, for example, image processing. You can define what certain images may look like. So you're not sure to get 100% output out of semi-supervised data, but I think this is where most of the kind of works leading towards. A lot of systems that we're using these days are more about semi-supervised. Guys, can everybody hear me? Because it's awfully very, very quiet.
I can hear you. I think we're good. Oh, don't forget, everybody's on mute.
Okay.
If anybody does want to talk as we're going through, here we go, look. Everything as we go through, just either ping your hand up and I'll unmute you, or pop a message in the chat and we'll do it that way instead.
Yeah, for some reason, I'm not able to get hold of my mouse pointer, I think because I'm in the presentation mode. So feel free to unmute and to speak.
Anybody who wants to, have an input, let me know.
Yeah, and by all means, share your views as well. If you have known about machine learning, and it's supposed to be more of an informative chat. Now, going on into the 4th category, that's the reinforcement. Now, reinforcement is basically heavily reliant on the output of the system that's producing data. So basically, autonomous vehicles. Yeah, you are you're actually dependent on what are the road conditions, which the data. So the data is captured by the system, processed, and then it decides what to do. So this is reinforcement is probably one of the most complicated kind of architectures and machine learning things to be implemented as of yet, and it is constantly developing. So what we're going to probably I'm going to reduce the scope of our discussion today. We'll probably be talking about semi-supervised and basically going into something like TensorFlow and showing how it works on a Kubernetes style architecture. I'm hoping there are no questions. I'm moving to the next page. So this is just a nice pictorial way of representing certain things, some more examples. I just thought I'd put this slide in because it looks good in terms of it's got a lot of good examples how it can be used. So yeah, supervised actually has both the category. Oh, sorry, there is a poll coming in between. Is it possible for you, Daniel, to move the poll out? Because I don't seem to get hold of my mouse.
What's up, sorry?
Sorry, just a second. I'm getting a poll that is...
Oh, sorry, it shouldn't have popped up. I wanted it to do it in the back end.
Yeah, I'll probably now push that back.
There you go.
Yeah, right. Then, so yeah, there's, again, there's slides available. So if you have any other discussions that you would like to have, I'm more than happy to have a chat with you. So existing solutions for machine learning. So this is more about the frameworks that help in doing machine learning. So TensorFlow, I think TensorFlow is really cool and quite prevalent. It's actually used for starters to just write some piece of code for machine learning, perform different kind of experimenting. PyTorch, which is Python driven, is primarily used for training neural networks and prototyping. So yeah, how the neural network is going to behave for different kind of information or the data. PyTorch is really cool. TensorFlow is catching up, but probably not as close as PyTorch. And then we have Sonnet. Sonnet is basically the TensorFlow version of PyTorch, but for neural network with complex architecture. So Sonnet actually provides a lower level TensorFlow integration into neural network architectures. And Keras is basically, it's a machine learning framework for starters. Now, all these frameworks can be used individually or can be used in combination. And I have used TensorFlow and Keras in where I consult at the moment, and it's really handy. And there are other frameworks, and so I've not listed down all the possible frameworks because this slide is going to be really messy. Then I've just listed down 10 basic machine learning frameworks that people talk about, and yeah, so nothing much. Just moving into challenges. Now, I think the key issue with machine learning is first understanding what kind of category it falls under and what kind of process do you apply. How do you automate it? Because you want some sort of data processing or some sort of processing to happen. So identifying which process fits in for that kind of automation. The other thing is lack of quality data. Essentially, there's a lot of uncategorized, unlabeled, untagged data, and it is it's not just to give you an idea, like the amount of data that you'd get out of US in terms of from a medical science point of view versus that you get from a different country, and you cannot apply the same kind of systems in both the places. So well, basically there is a data qualification that needs to be done, and that requires a lot of sanitization and a lot of selection process, and that is a big challenge. If we have the same kind of data coming, then it's at least, even if it's an unlabeled data, but you know that this data is predictable and is useful. The third thing is inadequate infrastructure. Now, it has been, before, like a few years back, it used to be a big challenge because enterprises cannot jump on using machine learning, because machine learning usually requires a lot of heavy infrastructure. And so the implementation, skills, and infrastructure have always been the three big challenges, apart from the data classification and understanding what kind of process that we need to apply. And today we're going to just show how easy it is to use something like Kubernetes style implementation and run your machine learning. Just again, a little bit more, why do machine learning on cloud? So the barrier for entry from bringing machine learning capabilities into enterprises was really high, as I mentioned in the previous challenging slide. And what has happened is, with the introduction of machine learning on cloud, it's been possible, but at the same time, if the implementation is not right, then you actually spend a lot of resources. And so if you don't write microservices and you just write monolith applications running on cloud, that doesn't make sense most of the times. And in such cases, you're actually running big beefy loads on cloud, but actually not utilizing the whole potential of the cloud. So Kubernetes offers, and that's where that leads me to the next one. So Kubernetes offers more as an orchestration over the cloud, so it just sits upon any one of the platform or more than one platform, and you're just interacting as a developer or as a business. You're interacting with the platform through this orchestration layer. You're deploying solutions in a prescribed manner, which is microservices, so Docker, containers. Now, I'm assuming all people in this call have some knowledge about Kubernetes and its architecture. If not, pardon me, but I think our time's too less to actually go delve into the details of Kubernetes in this call. Yeah, essentially, what the key thing about machine learning is, we want to do exploration, we want to learn, experimenting, and then start doing implementation. Now, exploration, there were always tools to do that using big data solutions. Learning was a challenge, but that's been resolved through all the frameworks that we talked about. Implementation and actually making the learning cheaper for enterprises is what cloud and Kubernetes is trying to resolve or solve. Yeah. So at this point, I'm actually, I think now when we jump into the demo, we actually start seeing how easy it is to run, a workload and just get some dashboards and metrics and things like that.
I'm just gonna unmute everybody, Soumen, if I can just figure out how to do it. And then what I was gonna say is, if anybody had any, oh, hang on. Oh, I thought I was gonna, here you go, yeah. I've unmuted you all. Do any of you have any questions before we move on? Nope.
Right.
Now I've unmuted you all, sorry, that's my mistake. It doesn't work, strange, okay. Yeah, let's move on then, maybe that doesn't work.
Let me see if I can get hold of the chat. Yeah, so I can see the chat now.
If not, anybody, like I said, just put your hand up and we can do it that way.
Right. So yeah, again, this is not the end of it, guys. So obviously you can reach me through Danielle, or I'll share my details after the call, and we can connect as well. Right. Yes. Oh, That's a good thing. I've actually not used the.
It's customizing it all.
Yes. Too much of US English. Now going on to yeah. So now before so I will be showing Jupyter Lab and Kubeflow to both of you. Sorry, to all of you. And as part of so I just want to clarify. Jupyter Lab used to be the key tool for data scientists, and even it is as of day to day. Most of the data scientists I interact with at my job, they are still very, very Jupyter Lab focused, but they do say I keep hearing a lot of challenges they have with Jupyter Lab, and they all look up upon Kubeflow, but Kubeflow is actually has just recently come through since last year and a half, and Kubeflow is actually picking up a lot of traction because it allows running your machine learning as pipelines in production. So you could actually run your workloads, machine learning workloads. Your model, the trained model, is available in production, and you can have production data going through those pipelines and being sanitized, or doing different kind of things around it. So Jupyter Lab or Jupyter Hub used to be more around data exploration, creating models, and training the models. Training model used to be cumbersome. So the way data scientists used to do is have Jupyter Lab running on a server, on a big beefy server, and they used to connect with their IDEs, which used to run PyTorch, and PyTorch used to connect uh, with Jupyter Lab, and they used to do the training of model. So basically creating the model and data exploration through their IDE, connecting to this Jupyter Lab, and then let the training happen on the server and trigger everything through PyTorch. So that's the sort of thing I've seen, I've heard them doing. Kubeflow gives all the capabilities of Jupyter Lab and running pipelines and performing experiments. So we just move, and I'm going to use the Google Cloud Platform for the demonstration here for everyone. So let's go into this. Right. So I can see this stuff. So just for everyone's, I am running my Jupyter Lab notebook on Google Cloud Platform, and which is running as a pod. And I've done a let me see if I can show this. Yeah, so I can perform git clone, so I can integrate with GitHub and get data out. All the instructions of how to do the setup, I can share it with all of you. Just to let you know, the entire end-to-end setup period to have all of this running on a Kubernetes cluster is somewhere with a cluster running on Google Cloud Platform. Bear in mind, setting something on Google Cloud Platform versus AWS and Azure is different, but on Google Cloud Platform, end-to-end probably taken me around 4 to 6 hours to get the whole thing up and running, what I'm showing right now. So yeah, so basically I have got hold of a TensorFlow notebook, which basically all it's going to do is like a quick big data query. So it's going to go through a public data set now and identify within between 2000 to 2005 how many children or how many kids or babies were born in the US, and segregate between how many were male and how many were female, and what were their gestation weeks. So now this, and the mother's age. Now this kind of data, if you see it, so from a medical science point of view, is very critical, and it is complex because there are different parameters. I have just tried to slim down just for the sake of the demo, And all I'm going to do is I'm going to run this query up, and it gives me some information. And now if I want to check, like, were the male babies heavier or lighter based on their gestational, in that period? So based on that data set that I've just got, and you'd see the graph saying, yeah, slightly heavier than the female babies. But I think the most complicated kind of thing is, and all of this is being done on cloud, and this can be just turned up and turned down, and yeah, you don't pay anything at all as far as infrastructure cost is concerned once it's switched off. So yeah, this is actually saying, and this is quite helpful, based on the gestation weeks, how many babies were actually of the right weight, and what kind of average weight they were. And if I were to run this, yeah, so I get, now all this information is being, so basically there's a kernel running in the background in Jupyter Lab, and I've loaded some data from the public data set, run some queries, and then I'm just performing different kind of queries on that, and making some graphs out of it. Now, obviously, showing this kind of information very easily to a client that if you're showing to someone from the medical profession, and obviously getting different kind of data. So just quickly writing it up and saying, so for example, if you were to say, so I want to just see from 2000, yeah, so 2001 to 2005. Yeah. So let's go through this. And let's check here. So from my perspective, all I've done is just done just a basic change, and all the other things reflect according to it. I could change this to limit to 200 records and see what, obviously that, because this query takes a little longer, but yeah, you see we do get so to just make it back to 100. Let's see. So you see this change in the weight in pounds. Now, obviously, the more data you gather, and you can actually go through that. Similarly, there is so this is more about running stuff on a Jupyter notebook kind of thing. This is actually machine learning algorithms being run. Now, I am also going to show you something like, so this is a much more complicated kind of data set, taking data set and making different kind of graphs out of it. So I'm just showing you bits of algorithms that are being plotted into graph. And for someone with the data scientist, someone like a data scientist, this kind of data would actually make a lot of sense. And yeah, so obviously, my main purpose is to enable the infrastructure for data scientists to deliver quickly and efficiently without having to spend a lot of time worrying about the infrastructure, and seeing different kind of data and then extrapolating or drawing out inferences based on those. And so this kind of information, I just run this. Let me just clear all the cells. So I'm just restarting the kernel and clearing out it. So that's all gone. And yeah, and now it's running. And when this completes, this will have a number, and this folder gets pre-populated. with the data sets. So you can see I ran this folder 2 hours ago. Once this completes, the timestamp on the content of this folder should change. So while I'm showing this, does anyone have any question? All the stuff around the setup of Jupyter Lab or Jupyter Hub is very, yeah, so you see a few seconds ago, you have this folder being created with a different timestamp. Right, so there is some question here, I think. Yeah, the data that we are talking here is not pretty big for now. Purely for the demo, I do not want to spend a lot of time on that, but I can actually share the data set with you, if you're interested. But it is, it's not like 100 records kind of thing. It is like a few hundred thousands of records, something like that. No, so I'm currently training on CPU node, but I can, obviously, I'm running on my own personal GCP cloud infrastructure. I could do it on a GPU node, and I have got a notebook that I used to do a demo upon for GPU based notebooks as well, which I can probably show you later. I'm pretty sure people may not be interested to see it now. Right. Okay, so going back, let's go back here. Oh, sorry, going back here. Yeah, so then I have got one here. So this is a very typical workload. Let me just cancel. So I want to clear the cells. Just want people to see that there's no preloaded data set here. Yeah, and so basically I've got two sets of instructions, one running on CPU, one on GPU. Now, if I have a GPU node, you would see the time taken to process the data will be significantly smaller, very, very less. But because I'm running just on CPU, I'm going to just run all cells. So let me go quickly. Yeah. So just give so you can see this took around 16 seconds to process these many results. If I were to do this in a GPU, this would be like 0.03 or something like that. Very, very quick. It's going to fail here because I do not have a GPU node running at the moment. If I were to run this in a GPU node, both of these would pass, and we'd see. Right, so there is some message coming. Let's see. I tried to. Can you all not hear me?
Yeah, we can hear you, but what
okay.
Yeah, I tried doing it so that I could unmute everybody so that they can obviously have a bit of an input, but I've no idea what I've done. I've probably set it up a bit funny, but I'll fix it for next time.
All right. Okay.
Cool.
Yeah, it just feels a bit lonely, right? No, because it's just me talking about.
Sorry.
Yes. Anyways, yeah, I love to chat, guys. It's just I do not want to blabber and keep boring you. So, anyways, quickly jumping. So we saw this as a Jupyter Lab running on. Yeah, it is running on my cluster. Blah blah blah. How does this go on? So this is the Google Container platform, and yeah, it's much more simple. Yeah, it's just so you spin up a cluster, and now I'm going to show Kubeflow, which is running on the cluster, And let's quickly jump onto that one. So Kubeflow, let's go to that. So this is what a Kubeflow dashboard looks like. Kubeflow allows you to create notebooks. So what is a notebook? This whole system, the Jupyter Lab, is running as on a server called a notebook server, which traditionally used to run on a VM, then running on a VM on a hypervisor in a like in a data center somewhere, then moving into an EC2 instance, now running within a pod, and with a EBS back storage if it's in AWS, or a persistent storage in Google Cloud. Yeah, so it's running as a stateful set. So all the data that I store, I shut this down, start it up, I'll have all my data available. It doesn't get lost. Obviously, you do have to pay for the data that you are storing as persistent storage. So coming back to this, so in Kubeflow, I can actually launch more than one of these instances. So now you can see Kubeflow is running within a pod. So that's why I talked about the transition, how things are moving. Something used to run on a server, moving into a VM, running on a server, moving into EC2 kind of, or a or on a node on a cloud, running within a pod inside a Kubernetes cluster. Now more than one such implementations running within a single pod. So that's how things are being optimized, and this is purely because you have a different landscape for your infrastructure, and people want to utilize the best possible approach they have. Obviously, Kubeflow, with Kubeflow, you have the capability of like spawning multiple notebook servers, and second, there's some chat coming. Yeah. Oh, that's Danielle again. Yeah, so just gonna first server running, and you could define what kind of image you want to pull. So I want to get TensorFlow 2.0, and how much CPU memory, and a persistent storage. You want to read write once, read write different kind of setup. You may want to mount different data volumes. If you want to add GPU resources, so add some kind of tags or annotations, and this will get then applied onto the pod that gets spun up. So basically, it's just to be clear, in Kubeflow, when I'm spawning up multiple notebook servers, each notebook is getting spawned up as a separate node, as a separate pod itself, but it's a pod controlling those pods, not an orchestration not to be done manually. So you are having the control plane running within in a pod, and you have the notebook servers running in separate individual pods. And if I hit spawn, yeah, so this will go away to create, and now when I want to connect to it, I can launch here. So, and I've just put some, the same TensorFlow images that I have. Now, the key thing here is I give the same kind of setup to a certain part of my team, and they can do data exploration and all the benefits of Jupyter Lab. Once all of that is done, I can actually get people to start using the machine learning pipelines and creating experiments. So yeah, I've not set my credentials up properly yet. Otherwise, I could have shown a full pipeline. But let me just show. Where's that going? This. Yeah. So it's basically some data being taken up from a storage, validated, pre-processed, training the model, some analysis happening in parallel, some prediction happening in parallel based on the trained data, and some deployment taking place. So, and each of these are separate Docker images or containers or microservices, and they are being chained together. Now, this kind of setup for data scientists is exactly what they were doing manually or in a scripted way. So take something out from here and then write a big, so they used to have like big kind of scripts and connect this kind of thing. So with Kubeflow, they can actually slot these in as steps and create a run out of it. So before they do an actual production run, they can create an experiment, they can validate how things go, and based on that, they can update. And all of this could also be generated into a YAML format, and this can be then config controlled in a Git repository. There's a lot more to it than what I'm showing today, but yeah, I'm just conscious of time. I've been talking for almost 15 minutes and haven't had any questions specifically, purely because something's going wrong with this microphone.